Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there was no stopping.
And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis I. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter.
All right, now let's talk about OTC-1, outbound trajectory correction number 1. So at this point, we've done our translunar injection, we're on our way to the moon. And to get there, we're gonna fine tune our path, we're gonna make a couple of different burns just to make sure we're targeting the right direction. Now the first one is this OTC-1 burn, and really this is a critical test of that large orbital maneuvering system engine that's right here in the aft part of the Orion service module. That's really what's going to be doing our big pushing maneuvers, and it's critical for those flybys, the powered flybys of the moon, both the one that allows us to get to distant retrograde orbit and the one that comes home. Additionally, we have these auxiliary thrusters around the bottom. We have 8 of these that can provide some additional push to help out with this orbital maneuvering system engine. But OTC-1 is coming up. We'll likely make a number of these burns on our way out to the moon, and all that sets us up for essentially this slingshot that we see here before we get to the outbound power flyby. You can see that engine igniting here. Testing it on this burn is going to be really critical to making sure that it works there, and that's what's going to allow us to get into our nice stable orbit around the moon, where we can really test Orion out, put it through its paces. So coming up, OTC-1, the first in many burns using that European service module on this Artemis I mission.